In this video, we're going to derive the rule of balance. Here I have a balance beam, and I'm going to put a 5 kilogram here on the left-hand side, and you'll see that'll tilt over. So the question is, what do I need to put on the right-hand side to balance it? So I can start with this 5 kilogram, and I can put it over here, and right now it's not balanced. But you'll notice that if I put it at the same distance away from the axis of rotation, or the fulcrum, or also known as the pivot, you'll notice that it does balance. So it looks like if you have the same mass and there's the same distance from the fulcrum, it balances. But what if I have a different mass, like a 10 kilogram mass? So if I put it at the same location, let's see if that balances. So now it doesn't balance. Let's see if I can find another location where it does balance. Maybe if I move it over here, and now it does balance. So the question is, can we come up with some sort of rule to be able to predict when this plank will balance or when it will not balance? So it looks like if I took this 5 kilogram mass and multiply it by the distance of 1, 2, 3, 4. So 5 times 4, I get 20. And on the right-hand side, I have 10 kilograms times a distance of 2, and I also get 20. So perhaps if the mass times the distance to the fulcrum on both sides is the product of the mass times fulcrum on both sides is equal, then it will balance. So we can come up with an equation that looks something like this. md on the left-hand side, mass times the distance, equals md on the right-hand side. So maybe m1 d1, m2 d2. So if they are equal, then the plank will balance. But does this work if we have two masses on the left-hand side? And we're going to test that out right now. So now I'm going to put a 5 kilogram, 1, 2, 3, 4 distance away, and a 10 kilogram over here. And then I'm going to try to balance it with a 20 kilogram. So let's see, would that balance if I put it right here? Okay, so that looks like that balances. If I put it over here, doesn't balance. Okay, so I have to put it at this location here. Now let's try our rule of balance, and let's see if that works for the situation. So we said earlier that the md on the left needs to equal the md on the right-hand side. So I have a 5 kilogram times a distance of 1, 2, 3, 4 times 4, and I get 20. And then for the 10 kilogram, has a distance of 1, 2 times 2, and I get 20. If I add this up, I get 40. So let's take a look at on the right-hand side. We have a 20 kilogram times a distance of 1, 2, and we also get 40 as well. So it looks like if the sum of the product of mass times distance on the left-hand side equals the sum of the product of the mass times distance on the right-hand side, if those are equal, then the plank will balance. Let's see if this works for 4 objects. All right, so now we're going to test our rule of balance with 4 objects. So we'll start with the 5 kilogram, and I'm going to put it right here. We're going to put the 15 kilogram right here, and a 20 kilogram right over here. Okay, so now I want to try to balance this with the 10 kilogram. I'm going to start at the end here. No, it doesn't work. I'll try over here, close to the fulcrum. Doesn't work. Move it a little bit away from it. And now it looks like it works. Okay, so let's test our rule of balance. Let's see if our rule of balance works for this situation. So our rule of balance so far is that if the sum of the mass times the distance on the left-hand side is equal to the sum of the mass times the distance on the right-hand side. So this is the left-hand side. This is the right-hand side. If they're equal, then it will balance. All right, so let's test it out. So we have a 5 kilogram by kilogram, 1, 2, 3, 4, 5, 6 times 6, and we get 30. 15 kilograms times 1, 2, so that would be times 2, that also would be 30. That gives us a total of 60. Okay, on the right-hand side, we have 20 kilograms times a distance of 1, so that's 20, and a 10 kilogram, a distance of 1, 2, 3, 4 of 4 That gives us 40. And so 20 plus 40, and we get 60. So it does work.